In this video, we are going to revise the science paper 2 for the year 2022, and this paper was written by the GCE. So we are going to begin with section A. So let's look at the first question. Question 1A, the branch of chemistry that deals with the identification of composition of substances is. So here, the key point is we are trying to find the composition, the identification of the composition, meaning what the substance has. So here, the analytical chemistry investigate what the substance is made of. So this one deals with the investigation of what the substance has. Then in organic chemistry, we are looking at chemistry that deals with the compound that does not contain carbon. So compound with no carbon atoms. Then what of organic? So we know organic chemistry deals with compounds with the carbon elements. Then for physical chemistry, this is the type of chemistry that tells us the relationship between chemistry and physics. Okay, so now from this we can see that the type of chemistry that deals with the identification of composition is analytical chemistry. So let's move on to question 2. The following diagrams shows the arrangement of particles in a substance under normal atmospheric pressure, but at two different temperatures. So we can see when the temperature is negative 125 degrees Celsius, we can see that this is giving us a solid substance. But if we are to increase, so since this is a negative number, if we add a positive number, this will give us negative 90. So we can see that negative 90 degrees Celsius is greater than negative 125. So this tells that for this substance to move from here to here, it means that the substance was heated. So we can see that if this substance is heated, it is changing from a solid to a gas. So somehow we are dealing with what we call sublimation here. So we have this sublimation because of what is happening. Now let's look at the multiple choices. Which substance could the diagrams represent? So the first one, A, we have negative 150, melting point, negative 150, boiling point, negative 138. Then B, negative 135, melting point, boiling point, negative 120. C, negative 120, then boiling, we have negative 88. So our answer is C here. Why? Because for this one to melt, it means a certain heat must be added. And if we add heat to this 125, we are expecting this number to move from this 125 up to 120. Because we know that negative 120 is greater than 125. So melting, we are adding heat here. Then for boiling, also it's for boiling. For us to boil, we know that we need to heat also, or we need to add it. So if we add heat, we are expecting to get a number less than 90. So which is negative 88. So that is our answer. Because if you check the numbers for these other multiple choices, you can see that these numbers indicates the greater or than, the less than this, of which is not true for melting and boiling. So we can now move on to question 3. The following diagram shows part of a laboratory thermometer. So here, so this line here indicates that we have 20 here. So we can see the calibrations, so the divisions, so we have 21, 22, 23, here is 25, 26, 27, so this is 28. So from the multiple choices, our answer is C. Then we move on to question 4. The following table lists the data obtained in a titration experiment. Which reading should not be included to compute the average volume of the acid used in the titration? So here we need to look at how close these numbers are. So the number that will show the greater difference will be the number that must be excluded. So let's look at the numbers. So from these numbers, I'll begin with 11. So the first number we have 11.9. Then from 11.9 we'll have 12.8. From 12.8 we'll have 12.9. From 12.9 we'll have 13.0. So let's check the numbers. So if we are to find the difference, the difference between 11.9 and 12.9, so let's do calculations here. So 12.8 minus 11.9. So the difference here is 0.9. Now let's check the difference from here up to here. So this will give us, we have 12.9 minus 12.8. So here the difference is 0.1. Even here the difference is 0.1. So we can see that these three numbers are related. They are closer to each. So these are the best numbers that we can use to calculate the average. So the number that is far from the other number is 11.9. So we can see that 11.9 is somehow showing an error. So this is the number that we are not supposed to add. So let's move on to question 5. The following diagram shows a chromatogram obtained when sample V was analyzed together with 4 other dyes W, X, Y, and Z. Full stop. Dye X was known to be poisonous. Okay, so now let's analyze this one. So the sample is our V. So this is our sample. Then we have the other non-dyes where we have this is our W. So W has 2 spots. Then for X we have 1 spot. Then Y we have these. Z we have this. Now let's focus on X, since we are told X is poisonous. So we are supposed to look at the other samples. If these other samples have spots that are corresponding with X, therefore they also consist the poisonous. So we are going to draw a straight line that will pass through these points. So if you see, we can see that V is part of X, which is poisonous. Here we have this spot which is poisonous. X, here we know X is poisonous. Then W is also poisonous. But for Z we can see that there is no spot for Z. So meaning this is giving us that Z has no spots that has poisonous. So let's look at the question. Which of the following dyes are safe for use? So the answer is Z only, because the other samples have spots that are corresponding with the poisonous X. So we move on to question 6 here. The following diagram shows the structure of an atom. So we have this structure here. We have the electrons. We know that the electrons are found in the shells. Then these are shells, or sometimes they are also known as energy levels, because each shell has a specific energy that it has. Then these subatomic particles with P, these are protons. Protons have a positive charge. Then these are neutrons. And we know that the protons and the neutrons are found on the nucleus of an atom. Now let's look at the question. What is the proton number and the nucleon number of the atom. So we want to find the proton number. Then the second one, we have to find the nucleon number. So let's look at first the mass number. So I'm using a mass number because this is the term that we all are common with. But the key point is the nucleon number is also known as the mass number. So how do we find the mass number? So mass number can be found by adding protons and the neutrons. So from this diagram, we can see that we have 1, 2, 3 protons. So we have 3 protons plus how many neutrons? So neutrons, we can see where we have this n here. So we can see that we have 4. So 3 plus 4 will give us 7. So we know that the nucleon number will be 7. Now what of the proton? The proton is just direct, no addition, no subtraction, no any calculation here. What you just have to do is you just have to count the number of protons that are there on the nucleus. So we can see that we have 3. So we need to have a multiple choice with proton is 3, then nucleon number 7. So our answer here is B. So we can now move on to question 7. Lithium occurs as a mixture of 2 stable isotopes. So we have the first one, this is LI, with the atomic number, mass number of 6, atomic number of 3. Then the abundance is this number, 7.5%. Then we have another atom with the mass number of 7, 3. Then the abundance is 92.5%. Now, how do we calculate the relative atomic masses of lithium given the abundance and the mass numbers? So here we calculate like this. So it should be, so we have relative atomic mass is equal to, so here we are going to say percentage of isotope nangu abundance over 100, then multiply by its atomic. So we'll consider the first one as atomic A, then plus C, since there are 2, this will be a percentage of isotope over 100 times B. We'll consider this one as B. So let's do calculations here. So the percentage for isotope A is 7.5 over 100 times Z. Then the mass number for A, so use the mass number for A is 6, so times 6 plus C. The abundance for B is 92.5% over 100 times Z. The mass number this time is 7, so multiply by 7. So let's do calculations. So 7.5 divided by 100, so I'm getting 0.075, then times 6, so here I'm getting 0.45 plus, then we have 92.5 divided by 100, so I'm getting 0.925, then multiply by 7, I'm getting 6.475. Then final answer, we need to add these two numbers. So this plus 0.45, so I'm getting 6.925. So if we are to round it off, I'm getting approximately 6.9. So from the multiple choices we have, this is our answer. Now let's move on to question 8. Magnesium forms magnesium plus ions. The number of electrons in a magnesium ion is, So here the key point is we want to find the number of electrons in the ion. So ion, we are looking at when it is charged. So how metals are charged? Metals becomes charged after losing electrons. So let's look at if we are to draw the original structure. We know that the mass number, according to the periodic table, the mass number for magnesium is 24, the atomic number is 12. So if we are to draw the original shell before the losing, the outermost shell will have 2 electrons. So we'll have 2 electrons. Then the second shell, which is, we call this one core shells or core electrons, will have 8 plus the other 2 in the first shell. So now let's look at what happens if the 2 electrons are lost. So if the 2 electrons are lost, we are going to have only 2 shells. So let's consider 2 shells. The first shell has 2 electrons, then the outermost shell will have 8 electrons. So we can see that now this atom is stable. So after it has lost 2 electrons, then we can see that it has attained the positive charge. This is now magnesium ion. So from this, we can see that the 2 electrons were given out. So the remaining electrons must be 10. So you just have to calculate to count the number of electrons in this ion. So we have our answer as our B. So we move on to question 9. Which elements exist as monatomic molecules at room temperature and pressure? So monatomic, we are looking at the elements that exist as just as one atom. Mono means 1. So let's look at the first one. And from the periodic table, group 8 are monatomic. So we can see that our answer is A, because helium, argon, and neon, all these elements are from group 8. The fluorine is group 7. Group 7 exists as diatomic. Chlorine also diatomic. Hydrogen also diatomic. So there is no other multiple choice with these elements. Now let's look at question 10 here. Deduce the formula of lead 2 sulfate. So whenever you are given this number 2, this means that our lead must have the valence of 2. Then let's hope, I didn't say, I said sulfate, so this should be phosphate. I take that back. So phosphate, the chemical formula for phosphate is PO4, but the valence is 3. Now we can see that these 2 numbers are not even, so we'll just use now the crisscross method, where the 3 will come here. So we are going to have 3 atoms of lead reacting with the 2 radicals for phosphate. So since phosphate is treated as 1, the 2 must go outside the brackets, since this 2 is affecting both the phosphorus and the oxygen. So this is our chemical formula. So our answer is C. Then 11. Which one of the following substances dissolves in water to form a solution with a pH of less than 7? So 0 to 6 shows the acid. So from these multiple choices, we want a substance that if it were to be dissolved in water, it is going to give us an acidic solution. So ammonia, we know that ammonia is a basic. Magnesium sulfate, this is just a salt, so this will not give us an acidic. Sodium chloride is also a salt. Sulfur dioxide, whenever sulfur dioxide dissolves in water, it produces the acidic solution. So this is the answer that we are looking for. So we have D. Then question 12. Dilute sulfuric acid reacts with both magnesium oxide and magnesium carbonate. How are these two reactions alike? So we want to find the similarity. So let's do this. So say we have magnesium oxide react with the sulfuric acid. We just write as a chemical formula. So what are we going to have? So we are going to have magnesium sulfate, then the hydrogen will react with oxide, will give us water. So during the reaction of N metal oxide with N acid, water must be produced. Now let's check this one. Let's say, for instance, we have magnesium carbonate. This react with the same sulfuric acid. So what are the products? Here we are going to have magnesium sulfate also. What else? We are going to have water plus carbon dioxide. So the points that we need to undertake here is whenever an acid reacts with a metal oxide, salt and water produce. Then if the reaction between dilute sulfuric acid and magnesium carbonate, this time we are going to have salt, water and carbon dioxide. So from these two reactions or equations, we can see that both of these are producing water. So our answer is A. Okay, so now let's move on to question 13. Crystals of sodium carbonate decahydrate. So decahydrate, it means the hydrate means we have water, then deca, it means 10. That's why we can see that we have 10 here. Then we are told efflorescent. When these crystals are exposed to air, the crystals, the first one gain mass and become liquid, B gain mass and remain solid, then C lose mass and remain solid. So whenever we expose these crystals of sodium carbonate, we are going to expect water. The water will evaporate. So as the water evaporates, then the mass reduces, since a certain amount of water with its mass has been removed. Then 14, 1 mole of nitrogen and 1 mole of ammonia gases have. So we are looking at ammonia, 1 mole. So this is, we are getting it from the Avogadro. So this is the more concept picture. Now, so 1 mole of nitrogen, 1 mole of nitrogen will have the same Avogadros, which is 6.02 times 10 to the power 23. What of 1 mole of ammonia? Even 1 mole of ammonia will still have the same. So this number is like, it's a number that, the point is, what can I say, like a dozen. It doesn't matter if we are looking at a compound or we are looking at an individual. The key point is whether it's a compound or an individual, the Avogadro's constant is always the same. That's why it is constant. So the answer for question 14 is A. These will have the same equal number of atoms. So we can't say equal electrons, number of molecules, equal number of molecules. So this is our answer. Then we go to question 15. A solution of calcium chloride contains 11.1 grams of the salt in 250 cubic centimeters of the solution. What is the concentration of the solution? So what is the formula for concentration? So we know that concentration is equal to number of moles divided by volume. So we have the volume, but we don't have the number of moles. So let's look at the number of moles. So number of moles is equal to mass. Since we have been given mass, we are going to use this formula, mass over molar mass. So let's look at, we have the mass 11.1 grams, then the molar mass. So the molar mass, we need to go back to calcium chloride. So calcium has a valence of 2, chlorine has a valence of 1, so the chemical formula will be this. So the molar mass will be calcium times, we only have one atom here, plus chlorine times 2. So the mass number for calcium is 40 times 1, plus for chlorine is 35.5 times 2. 40 times 1 will give us 40, plus 35.5 times 2 will give us 71. So if we add, we are going to get 111. 71 plus 40 will give us 111. So therefore, molar mass is equal to 111 grams per mole. So we can now divide by 111 grams per mole. So let's do now the computing. So 11.1 divided by 111. So this is giving me 0.1 mole. So this is now the number. So the number of moles is 0.1 mole over the volume. Now the volume is in cubic centimeters, so it has to be converted into cubic decimeters. So say 1 cubic decimeter is equal to 1000 cubic centimeters. So let's do, so this 250 will be here, then we put x, we cross multiply, so this will give us 1000 cubic centimeters x. Then here we have 250 cubic centimeters decimeter, then we divide by 1000, also here by 1000. So we can see that if you do the cancel, we'll get 0.25 decimeter cubic. So we are dividing by 0.25. So what is 0.1 divided by 0.25? So I'm getting 0.4. So the final answer is 0.4 mole per decimeter cubic. So now the key point here is, from if you are converting from decimeter to centimeter cube, you need to multiply by 1000. Then the opposite is also true for converting from cubic centimeters to decimeters. So the key pattern here is, if you have been given volume in cubic centimeters and you want to have it in decimeter cubic, just divide by 1000. Then our final answer, we know it's 0.4. Then we move on to question 16. When an excess of magnesium powder was reacted with dilute hydrochloric acid, the reaction was fast at first but gradually became slower and finally stopped. Which of the following best explains why this happened? So we are looking at the rate of a chemical reaction. So let's look at so A, hydrochloric acid was used up. B, magnesium was used up. C, magnesium particles became coated with the hydrogen gas. D, temperature of the mixture decreased. So here we are told an excess of magnesium. So magnesium was in excess, so this one was not used up completely. So what made the reaction to stop was the hydrochloric acid was used up completely. So this is acting as a limiting reagent. So our answer here is A. So we move on to question 17. What could be the chemical formula of the nitrate of an element Q of group 3 of the periodic table? So let's look at Q. So group 3 elements have the valence of 3. Then nitrate is a radical with a valence of 1. So if we cross these numbers, we are going to have this formula Q with 1, Then nitrate, since it's a radical, we need to assign the 3 outside here. So this is our chemical equation. So our answer is D. Question 18. Some metal ores are roasted in air before they are reduced in the blast furnace. What is the main air pollution caused by this process? So carbon dioxide is produced, carbon monoxide is produced, lead fumes are produced. So the gas that is very, very negative in terms of causing impact to the environment is sulfur dioxide. So we move on to question 19. The following structures represent different types of soaps. Okay, so then which statement about soap is correct? A soap is a salt. Soap is a salt. Then we go to question 20, the last one for section A. What could be the structure of the polymer formed when the following monomers undergo polymerization? So let's look at this. So this is a dicarboxylic. Why? We have 2 functional group. Di means 2. We have 2 functional group for an acid. Then here, this is a diol. We have 2 functional group for what? For alcohol. Now, what happens if these 2 react? So what you need to know is from the acid party, we are going to remove the hydroxide. Then from the alcohol party, we are going to remove the hydrogen. Why? These must form water. Then from there, we are going to connect whatever that remains. So the key point here is we just want to see the linkage that is going to form between the 2 boxes. So my focus is what is forming if we are to connect these 2. So we have the box here. Then we can see we have the carbon. Then we have this one. Then this oxygen will go on top. We have this carbon, then this oxygen here. This oxygen, then this. So our point is we need to choose an answer where we have this type of linkage, and we call this linkage as Easter linkage. Then we need to make sure that the 2 boxes are not shaded. So let's look at this. So this cannot be the answer. Let's check here. We can see the linkage is not matching. Then also this is not matching. The linkage is matching. We can see that the linkage is matching, but this box is shaded. This one is unshaded. So the answer here is D. Why? Because the linkage is matching and the box are not what? The boxes are not shaded. So let's now dive into section B. The following experiment was set up to investigate factors that affect the rate of diffusion in gases. During the experiment, a cloud of white smoke was seen as the ammonia gas and hydrogen chloride gas reacted. So we can see from the left side here we have cotton ore soaked in ammonia, so there is ammonia here. Then on the right side we have cotton ore soaked in hydrochloric, then tube T, then we have point A, B, C, D. Now let's look at the first question. Define the term diffusion. So diffusion is the movement of particles from the region of higher concentration to a region of lower concentration. So that is the definition. At least almost everyone knows this definition. So let's look at question B. Which of the particles for ammonia or hydrochloric acid will move faster? Now, Here I want to give you one of the concepts that you should be using whenever you want to know the gas that will move faster. We just don't want to master this point. We know that ammonia moves faster than hydrochloric acid. Now let's look at how can we know. If maybe, for example, you are given carbon dioxide and oxygen, so how can you know that this gas will move faster than the other one? So the first one, what I'm going to show you is this. You need to do this. So we are going to find the mixture for each gas. So let's find the mixture. We know that the chemical formula for ammonia is NH3. So the mixture will be N times 1 plus H times 3. The mass number for nitrogen is 14 times 1 plus hydrogen is 1 times 3. So if we multiply 14 times 1 will give us 14 plus 3. This will give us 17, which is as a molar mass is 17 grams per mole. Now let's check for hydrochloric acid. So here we are going to say mixture is equal to, so here we have HCl. So there is 1 atom of hydrogen plus 1 atom of chlorine. The mass number is 1 times 1 plus here 35.5 times 1 plus 35.5, which is here we have 36.5. So these two numbers, we can see that we have two gases with different molecular weight. So what this means is hydrochloric acid is heavier than ammonia because its weight is greater than ammonia. So if this is the picture, we can see that we are expecting the gas that is lighter to move at a faster speed. So our answer here is ammonia. Ammonia will move faster than hydrochloric acid. So this is the picture that you should always use whenever you are trying to identify the gas that is moving faster than the other one. So you calculate the masses, then you compare. The one with the smaller number will move faster than the other one. Then let's look at C1. C1 will have okay, so we have at which point A to D along the tube will the white cloud see. So if we are to react, the equation is like this. So we have ammonia, a gas, 3 here, a gas, plus HCl, which is this. Since it's a gas, we'll just say a gas. Then this will react to give us ammonium chloride. So ammonium chloride. So the ammonium chloride is what is giving us the white fumes. So the point is, where will these two react? So is it point A, B, C, or D? So we said this ammonia is moving in this direction. Then the hydrogen chloride is moving in this direction. And we said ammonia will move faster. So they are expected to meet by point C or D, since this one will cover twice the distance of the hydrochloric. Why? We can see that if we multiply 17 times 2 will give us 34. So 36.5 is twice the number of that. So the speed of ammonia will move as twice as that. So we are expecting these two to meet at point C or D. So say at point T, let's look at it. So twice will be, because the half is here, so we'll say C, between C and D. So between C and D. Explain your answer. So this is because the ammonia will travel faster than hydrogen chloride. So hydrogen chloride, and hence these two will likely to meet at C or D. Then we have question D. State the first one, factor that affects the rate of diffusion in the experiment. So in the experiment here, we are factors. So we are during the experiment about fumosine, ammonia. So which factor are we talking about here? So diffusion. Then we can also look at this is the concentration, because the heavier one is telling us it is more concentrated. So concentration, or also size of the particle. Since according to our calculation we said that one is heavier, so size of the particle. Then safety precaution you would take when carrying out the experiment. So the first one, by wearing goggles to prevent these two gases from entering our eyes. Okay, so now let's move on to question 2. Question 2 reads, the following are some common substances. So we have air. So air, we know that it's a mixture of gases. So in the same air, there is oxygen, there is nitrogen, there is carbon dioxide, there is methane. So we have so many gases here. Then water, we know water is just hydrogen and oxygen. Then under limestone is calcium carbonate. So we have CaCO3. Then sugar, we can see that sugar we have C6H12O6. Common salt, we have sodium chloride. Brass is an alloy with copper and zinc. Calcium is just a pure element. Petroleum is a mixture with different molecules, like we have methane, we have paraffin, we have kerosene. There are so many mixtures. So now let's look at the question. Choose from the above list a substance, which is the first one, compound containing 3 elements. So we can go with the limestone. We know that limestone, there are 3 elements, calcium, carbon, and the oxygen. Even sugar. Then let's look at B, mixture of 2 elements. Mixture of 2 elements. So mixture of 2 elements. So here it's not a compound, but mixture of 2 elements. We have our brass. So we have our brass. Since copper is an element, zinc is also an element, which is a metal. So mixture of 2 elements. Then for C, mixture containing both elements and the compounds. So we have air, because in air we have oxygen, which is an element. We have carbon dioxide, which is a compound, ammonia, and so on. Then D, a mixture of compounds. It is petroleum, because in petroleum there are so many compounds that are there. Then we move on to question 3. Atoms of J and K have 8 and 12 electrons respectively. So J has 8, so the first shell is 2, the outermost shell will be 6. Okay, so it is in group 6. Then for K we can still have 12, so the first shell 2. Then we have 8, 8 plus 2 is 10, so the outermost shell will have 2. So this one is in group 2. So let's go to Roman number 1. A, determine the formulae of the compound or molecule formed by the combination of J and K. So J and K is a metal, since we can see we have 2 electrons in the outermost shell. So we have 2. Then J is a non-metal with 6 electrons in the outermost shell. So atoms with 6 electrons in the outermost shell have the valence of 2. So since these two numbers are even, we can cancel. So the chemical formula is just Kj. Then for Roman number 2, Jj. So Jj, we know that this is a non-metal react with the same non-metal. So this is, we are going to have a diatomic molecule, which is J2. Then for B, in each of the cases shown in A1 above, name the type of chemical bond formed. So in each of the cases, so the first one, K and J will have ionic bond. Why? Because there is a metal and a non-metal. Then in Roman number 2, J squared will have covalent. Will have covalent bond, since these are just non-metals. Then for question C, give 2 properties of the compound formed in A1. So A1, we said it's ionic compound. So what are the physical properties of ionic compound? So the first one, they conduct electricity. They conduct electricity when in molten state. Then the second one, they have a high boiling and melting point. Then let's go to question 4A. What is the major characteristic feature of an acid? So an acid, we know that when they dissolve in water, they produce positive hydrogen ion. So they produce positive hydrogen ion when it dissolves in water. Then B, explain what is meant by each of the following terms. So a weak acid. So a weak acid ionizes partially in water. So we'll say ionizes. These are acids. These are acids that ionizes partially in water. So if you put this in water, only part of it will dissolve, the other part will remain undissolved. Then Roman number 2, strong acid. These are acids that ionizes completely in water. And examples of strong acids, we have nitric, sulfuric acid, These are, even hydrochloric acid is an example of these strong acids. Then for question C, write equations to show the ionization of the first one, dilute sulfuric acid. So how do we write ionization? So first we need to write the chemical formula for sulfuric acid. So it is H2SO4, which is in aqueous. So the first one, this will first ionize. Then if we ionize, we are going to remove one hydrogen. So remove one hydrogen, which is we have plus aqueous. So if we remove one hydrogen will remain here. Then after removing one hydrogen, we are going to have a minus 1. Then the second one, we get now hydrogen sulfate. So if now we are going to remove another hydrogen, so we remove another hydrogen, then we can see that this time we are going to have this -2. So the -2, it means now we have removed the 2 hydrogens. So we can cancel what we are seeing are the same. So we can cancel this, we cancel this. Then our net equation will be sulfuric acid is equal to, we can add these two, will give us 2H plus aqueous plus the sulfate minus. So the final answer here is, whenever I want to ionize sulfuric acid, you write the symbol. So if this seems complicated or maybe hard for you, you can just get a picture. So you need to remove the hydrogen. So this is our hydrogen here. Then we know it's aqueous. Then this number 2 here, you put it in front if you want to have a balanced chemical equation. Plus the sulfate, which is aqueous, then minus 2. Then for ethanoic acid, we know that the chemical formula for ethanoic is CH3, then COOH, aqueous. Now, the ethanoic acid is a weak acid. So, whenever you are trying to ionize weak acid, you need to use a double arrow. These are reversible, since we are saying only partially or part of it will ionize. So, here we are going to have CH3, Cu. Then from the Cu, you indicate the minus sign, then plus the hydrogen. You can begin with hydrogen or N. So this is how you can ionize. So we can now move on to question 5. Excess of zinc metal was added to 200 cubic centimeters of 2 molar hydrochloric acid. Then write the balance equation for the reaction. So let's look at it. We have zinc. Zinc is a metal plus hydrochloric acid. So what are we going to have? We are going to have salt and water. So the salt and hydrogen, since it's just pure metal here. So we are going to have the salt, and our salt is zinc chloride plus hydrogen gas. Now let's convert this into a chemical equation. So the symbol for zinc is Zn, solid, plus HCl aqueous. So zinc has a valence of 2, chlorine has a valence of 1. So we know if we interchange, this will give us zinc chloride 2 aqueous plus hydrogen. Whenever we are writing hydrogen, we write the atomic if it's not in a compound. So we can see that we have 1 atom of zinc here, there is only 1 here, also 1 here. So the need of balancing is just for chlorine and hydrogen. So we just put a 2 here. So you can see that we have 2 atoms of hydrogen, 2 atoms of chlorine on each side. Now we move on to question B. Calculate Roman number 1, the number of moles of hydrogen gas produced in the reaction. Now let's look at what we have here. So we have the volume and concentration of hydrochloric acid. So what we are going to do here is we are going to find the number of moles of hydrochloric acid. Then we use mole to mole ratio. So let's find the number of moles. So the number of moles, if you are given concentration and volume, so this will be number of moles is equal to concentration multiplied by volume. So what is the concentration? Is 2. What is the volume? Volume is 200 cubic centimeters. Remember, we said volume should be in cubic decimeters. Okay, like that. So this 200, I gave you the picture, should be divided by 1,000. So this will be 0.2. So if we multiply 0.2 times 2 will give us 0.4. So 0.4 moles. These are moles for HCl. But the question is, we want the moles of hydrogen. So let's look at the HCl. So we write HCl is here. Then hydrogen is here. So we are going to use the mole ratio. So the mole ratio is the number in front of each compound or molecule. So the mole ratio for HCl is 2. The mole ratio in front here, since we don't have a number, this shows that we have a 1, so it's 1. Then we look at between the two, which one are we solving for? We are solving for hydrogen, so we put X here. Then 0.4 moles is for this one, so we put 0.4 here. Then we cross multiply. So 2 times X will give us 2X. 1 times 0.4 will give us 0.4 moles. Then we divide by 2. So X is equal to, so 0.4 divided by 2 give us 0.2. So 0.2, these are moles. So we have the moles of hydrogen. Okay, so now let's look at the Roman number 2. So Roman number 2, we want the volume of hydrogen gas produced at RTP. So if we are given this condition, RTP, the molar volume is equal to 24 cubic decimeter. So what is the formula? Number of moles is equal to volume. Number of moles is equal to volume over molar volume. So over 1, we cross multiply, so we know that volume is equal to number of moles multiplied by molar volume. So the number of moles, we have it is here. So the number of moles of hydrogen gas is 0.2 times 24. So if we multiply 0.2 times 24, we'll get 4.8. So I'm getting 4.80 cubic decimeters. So this is our answer here. So let's go to question C. Question C, we want the mass of zinc. What mass of zinc was used in the reaction? Okay. So the reaction, we have it, it's zinc plus 2 HCl. Then we have zinc chloride plus hydrogen gas. So let's look at what we have. So the number of moles for do we have the number of moles for zinc? We don't have. The number of moles for acid, we have it. We say it is 0.4, hydrogen was 0.2. So we want mass. So let's look at the formula. So mass is equal to number of moles multiplied by molar mass. So now we need the number of moles of zinc. So we are going to use the same relationship, ratio mole to mole. So say zinc HCl. Zinc has a mole ratio 1 here, then here we have 2, then the number of moles we have 0.4, we put X. So now 2X is equal to 0.4 over 2. X is equal to 0.2 moles of zinc. So this tells us that we have 0.2 moles of zinc times then zinc is just an element here, it's not a compound, so we just get the mass for zinc. So according to my periodic table, zinc has 65 grams per mole. So this mole will cancel. So 65 times 0.2, I'm getting 13 grams. So this was the mass of zinc. Then the other picture that I would like to share with you is, since we have the number of moles for hydrogen, so hydrogen is 0.2. So since hydrogen has the mole ratio of 1, then zinc has also the number of the mole ratio of 1. So these two will have the same number of moles. So whenever you have two compounds or two substances with the same mole ratio, they are going to have the same number of moles. Then we go to question B6. The following table shows elements coded with letter Q to Y which do not represent the actual symbols of any of these elements in the periodic table. You need to use the letters in some of your answers. So before we look at an example, let's look at before we look at the question. So this is group 1. Here we have group 2, group 3, group 4, 5, 6, 7, then we have group 8 here. Then question A, which element shown, the first one, Roman number 1, forms ions with a single negative charge? So the elements that form single negative charge are those from group 7, because group 7 attain stability by gaining 1. So it can be W and X. Then Roman number 3 has 3 electrons in its outermost shell. So elements from group 3 have 3 electrons in the outermost shell. That's why they are found in group 3. So it's V. Then how many protons does an atom of Y contain? So this is the period 1, period 2, period 3, period 4, period 5. So you can see that Y is in period 2. Since it's in period 2, it's in period not 2, 1. Y is in period 1. All the elements in period 1 have 1 shell, and we know that 1 shell is filled with 2 electrons. So here we are going to have 2. You can also use the periodic table to identify this one. No? You get the same answer. So we know that helium has the atomic number of 2, so the protons are 2. Then state the element which is the most reactive. The first one, metal. So metals, when you look at the metals, you know that elements from group 1 are the most reactive. Now, the other thing, according to the periodic trend for group 1, when you go down the group, their reactivity increases. So the most reactive from group 1 is T. So here we have T. Then non-metal, it's opposite to group 1. So here we move here. So this will give us W. Then D, deduce the formula of the compound formed between elements U and W. So let's go back. Element U is coming from group 2, so it has a valence of 2. W, you know it's group 7, it has a valence of 1. So if we cross, this will give us U, W2. Okay, so now let's move on to question 7. The following reaction scheme shows what occurs during the extraction of zinc metal from its ore zinc blend. So we can see that here we have zinc blend roasted in air. Roasted, it means it reacts with oxygen, giving us solid Y plus sulfur dioxide, then burn in coke to give us zinc plus gas M. So before we look at the questions, let's look at this equation. So the reaction of zinc blends with this one. So zinc blend has this chemical formula. So it's zinc sulfide plus oxygen will give us zinc oxide plus sulfur dioxide. Then the second one, the zinc oxide will react with carbon. So the carbon is a reducing agent here. We are going to have zinc plus carbon monoxide. So that's what you are going to get here. Then Roman number 1, question 1, deduce the chemical formula of zinc blend. So zinc blend is zinc sulfide. Name solid L. Solid L, so this solid L will be zinc oxide. So solid L is zinc oxide. Then our M is carbon monoxide. Then construct the chemical equation for the reaction of solid L with coke. So we want this equation here. So it's we have zinc oxide solid plus carbon solid. So carbon is more reactive than this, so it will displace zinc, giving us zinc solid plus carbon monoxide, which is a gas. So our equation is already balanced here. Then sulfur dioxide is a pollutant. Explain its effect on plants. So the first one, it produces acidic rain, which later destroys the plants. So how is this done? So this is done when there is too much acid in the soil becomes the acidic. And you know that there are some plants that cannot survive in an acidic environment. So we go to question 8. The 4 hydrocarbons given are members of a homologous series. Okay, so the first one we just have this, so it's methane with 1 carbon. Then the second one, 4 carbons, 1, 2, 3, 4. We are going to have the single bonds. Then the 10 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have seen the pattern. Then here we are going to have 6, like that, even up to 10. Then explain the term hydrocarbon. So these are organic compound with which contains hydrogen and carbon atoms only. So these are organic compounds which contains hydrogen and carbon atoms only. Then for question B1, name the homologous series to which the above hydrocarbon hydrocarbons belong. So we can see that we only have single bonds here, single bonds. So whenever we have single bonds, we have alkanes. So where the suffix is ane. Then compound with the molecular formula. Name compound with the molecular formula C4H10. So the prefix for 4 is bute, because it is like this. So meth 1, eth 2, prop 3, bute 4, pent 5, hex 6, hept 7, oct 8, non 9, dec 10. So these are prefixes. So we have bute. Then since we have the single bond, we are going to add the suffix of ane. So we have the butane here. Then draw the full structure formula of the hydrocarbon, which has 4 carbon atoms. So we have 1, 2, 3, 4. So remember, we are going to have the single bond since we are dealing with the alkenes. So you make sure that the carbons between the bonds between carbon must all be single bonds. We need to have sigma bonds here. Then which of the given hydrocarbons has the highest boiling point? So how do you know that this has the highest or lowest? So the highest boiling point is determined by the compound with the more number of carbons. So from this we can see that it's C10, H22. Because for us to break these bonds, we require a lot of energy. So now we can move on to question section C, question 1. The following schemes shows reactions of a dilute acid A. Then let's look at these 3 reactions. So we have the first reaction, substance B. So whenever this react with substance B, what are we getting? Sodium sulfate. So in this acid, there should be a sulfate. Then in this substance B, there should be sodium, since from this product we are able to see. So there should be sodium. Now, what substance can react with an acid to give us a salt? Sodium sulfate is a salt to give us a salt and water. So we need to have a base. So this is sodium hydroxide here. Then for here we have magnesium. So substance C, since we know that this is sulfuric acid, dilute acid A is sulfuric acid, this will give us magnesium sulfate. Then let's look at this one. So this one will be, we have copper oxide. So copper oxide plus sulfuric acid. This will give us copper sulfate. Copper oxide, yes, as a reactant. So copper oxide as a reactant, this will give us copper sulfate plus water. So this one is given, we are able to see. Now let's look at question A. Name and give the formula of Roman number 1 acid A. We know that this is sulfuric acid. Then the chemical formula is this one. Then substance B, we know that substance B, we say sodium hydroxide. Then for C, we know that C is magnesium sulfate. Okay, so now let's move on to question B. Construct, Roman number 1, a balanced chemical equation for the reaction between substance B and dilute A. So we know that substance B, we said is sodium hydroxide. Sodium hydroxide is a base, and we know that whenever we react a base with an acid, which is sulfuric acid, we are going to get salt, which is the sodium sulfate, and the water. So the chemical formula for sodium hydroxide is NaOH aqueous plus C sulfuric acid is this one, also aqueous. Sodium has a valence of 1, sulfate has a valence of 2, so our chemical formula will be like this, also aqueous plus C H2O. So we just have to make some balance equation here. So where can we balance? So we just have to put 2 here. So 2 sodium, then we have 2 oxygen from sodium hydroxide and 4, which is 6 from this acid. Even here we can see that we just need also a 2 here, so that we have a balanced chemical equation. Then for question Roman number 2, ionic equation for the reaction. So let me see if I have some spaces where I can write this. Okay, so I will write it here. So ionic equation, we are going to sodium hydroxide, will break it into ions, so it is Na plus aqueous with the 2, then hydroxide is this one minus aqueous, a 2, so that I want to have it in a balanced form. Then hydrogen plus aqueous, then that 2 will come in front, plus the sulfate minus 2. Then the sodium sulfate will also be in ions, sodium sulfate plus aqueous. Then we have 2 here, sulfate minus plus C water, 2 molecules of water, like this. So here we need to cancel the spectator ions. So the spectator ions are those that are in the same state before and after the reaction. So sodium is a spectator ion, then sulfate is also a spectator ion. So our net ionic equation will be 2OH minus plus C 2H plus aqueous, then is equal to this. So this is our answer, or if you want we can reduce by dividing each part by 2, since we have the same 2, but the point is this is our final answer. So if you divide, then this will give you hydroxide minus plus C hydrogen plus, then we get 1 molecule of water. Okay, so now let's go to question C2. Before C2 there is a question, this one. So state the type of reaction that occurs in B1. So B1, the reaction is neutralization. Why? It's a reaction between a base and an acid. So here we have neutralization. Then we move on to question C2. Calcium hydroxide or slaked lime is an industrial alkali. Explain the meaning of the term alkali. So an alkali is a base. It's a base that dissolves in water to form hydroxide negative ion. Then how Explain how calcium hydroxide is produced starting with limestone. So where can I write these points? So I'm writing these points here. So the first one will say calcium carbonate, which is limestone. Calcium carbonate is heated to form calcium oxide and carbon dioxide as a byproduct. So the equation is this one. So this is our equation for this point. So calcium carbonate, then we get calcium oxide plus C, then here we are going to have carbon dioxide. Then the second one, after we have this one, the calcium, so the other point is calcium oxide will react with water to form calcium hydroxide, which is slacked lime. Then our equation is calcium oxide plus water. Then we have this calcium hydroxide is this. Okay, so we have this is our balanced chemical. So these are the two steps, I mean the points that you're supposed to give, since we were looking at how calcium hydroxide is produced. So these are the two steps. So we have the 3 marks. So the 3 marks, even the equation, by giving this equation, we are able to get the 3 marks. Then B, give 2 large scale uses of calcium hydroxide. So large scale, the first one, calcium hydroxide is used in treatment of acidic soil. Then the other one, we can give this for, let's say, painting of buildings. So painting of buildings, then also is used in the treatment of acids in the waste, industrial waste product, also that is used. Then for question C, a weak solution of calcium hydroxide is called lime water and it is used to test for carbon dioxide. Construct a chemical equation for this reaction. Include state symbol. So here we are looking at that test for carbon dioxide, which is intense lime water milky. So the equation that summarizes the test for that is this one. So it is, you say it's calcium hydroxide, which is react with the carbon dioxide. So this will give us calcium carbonate. So have solid, we have a gas, we have aqueous here. So if these two react, whatever, so calcium carbonate plus we are going to have also water. So we need to have water. So then let's check for, is it balance? So the equation is balance. Then give the chemical name of the salt produced during the reaction. So it's calcium carbonate. This should be not water, this should be hydrogen. Yes. So they describe what is observed during this reaction. So bubbles will be produced. Bubbles will be produced. So the bubbles will indicate the production of hydrogen since it's a gas. So bubbles will be produced. Okay, so it's hydrogen. This. So let's check how can we balance this one. How can we balance this one? So we just have to put a 2 here and also a 2 here. Even if we don't balance, we are not taught to balance it, so that's okay. Let's go to the last question. Question 3. Propene is one of the main important hydrocarbons obtained from crude oil. Like propane, it is made up of molecules which contains 3 carbon atoms. Draw a structure formula for propene. So here we have structure. So let's look at propene. We are looking with E. So the general formula is CnH2n. So prop means 3. So where there is N, we have 3. Here we have 3. So C times 3 is C3 times 2 times 3 will give us 6. So the formula, this is 1, 2, 3. Then here, since we have E, we need to have a double bond. So this is our structure formula. Then how does propene differ from propane in terms of bonds? So propene has double bonds. All alkenes have double bonds. Then Roman number 3, to which group of hydrocarbons does propene belong? It is alkene. Then give the molecular formula for propane and propene respectively. So let's find for propane. So the propane is an alkane, so we need to use CnH2n plus C2. So we have C3 plus 2. So C times 3 is C3. 2 times 3, 6 plus C2 is 8. So propane is C3H8. Propene, we've already found it. So propene is this one, C3H6. Then B, Roman number 1, explain why propene reacts immediately with bromine water, whereas propane does not. So because it is unsaturated. If you want, we can say because it has a double bond, so it has a pi bond that is ready to react with bromine. So because it is unsaturated, we know that unsaturated means it has a double bond. Then describe what would be observed during this reaction. So we are going to have a colorless solution. This is what we call decolorization reaction. Then C, propene is obtained by breaking down longer chains of hydrocarbon. What is this process called? So we call this one as cracking. Then propene is a monomer for making an important plastic. State the name of the polymer it forms. So if we use propene plus, let's say, another propene, the polymer begins by the word poly plus the monomer, so then we have polypropene. So this is how we can answer this, and that is for this video. Thanks for watching.